Okay, how are you guys? I'm going to show you how to solve second order homogeneous differential equation. So in general, it takes the form ay prime prime plus by prime plus cy equals to 0, where a, b, and c are constant coefficients. So this differential equation has a characteristic equation. It is a characteristic equation of the form a m squared plus bm plus c equals to 0. So this characteristic equation is also roots of the form m equals to minus b plus or minus the square root of b squared minus 4ac over 2a. So as our first case, I'm going to call it case 1. When we have the discriminant of the roots b squared minus 4ac greater than 0. So if we have our roots being greater than 0, it means we have two real roots, m equals to a or m equals to b. So in that case, we get our general solution for the differential equation above as y equals to a e to the power ax plus b e to the power bx, like that. So for instance, let us consider a case where we have y prime prime plus 3y prime minus 4y equals to 0. So this is the characteristic equation, m squared plus 3m minus 4 equals to 0. So factorizing that, we get m plus 4 times m minus 1 equals to 0, which gives us roots m equals to minus 4 or m equals to 1. So after doing this, it means our general solution will take the form y equals to a e to the power minus 4x plus b e to the power x as above. So our first case is done. So we are going to consider a second case. In our second case, which is case 2, that is when we have b squared minus 4ac equals to 0. If we have this discriminant being 0, what it means is we still get a real and repeated root. So we are going to call that root, let's say, a. So if we have that real and repeated root, what it means is our general solution will take the form y equals to a e to the power ax plus bx e to the power ax. So that will be the general structure of our roots. For instance, let us consider y prime prime minus 6y prime plus 9y equals to 0. This also has the characteristic equation m squared minus 6m plus 9 equals to 0. So factorizing that, we get m minus 3 squared equals to 0, which then give us m equals to 3 twice. So it gives us m equals to 3 twice, which means our general solution will be y equals to a e to the power 3x plus bx e to the power 3x, like that. Okay, so we are now left with a third case. So the third case is when, when we have the discriminant being less than self. So the third case, which is case 3, where we have b squared minus 4ac being less than self. That is our final case. So in this case, we get the roots of the characteristic equation taking the form a plus or minus bi. So in that case, the general solution to our second order differential equation will take the form e to the power ax in bracket a cos bx plus b sine bx, like that. So that will be the general form of our solutions. Okay, let us consider y prime prime plus y prime plus y equals to 0, which is the characteristic equation, m squared plus m plus 1 equals to 0. So that will be our characteristic equation. Okay, so this characteristic equation, we can't factorize it. So what it means, we have to use the quadratic formula to solve it. So it means its solution will be m equals to minus 1 plus or minus the square root of 1 squared minus 4 times 1 times 1 over 2 times 1, using the quadratic formula. This simplifies to minus 1 plus or minus the square root of minus 3 over 2, which means our roots are minus half plus or minus root 3 over 2i. So these will be the roots of the characteristic equation. Okay, so the general solution to our second order differential equation will take the form e to the power minus half x in bracket a cos root 3 over 2x plus b sine root 3 over 2x. Then we are done. Thank you very much for following, and if you have any questions, please you can leave a comment